All right, ladies and gentlemen, I want to do number 64 in 1.4, which has some words, which are kind of biology related. It also has a formula. So I copied the formula down first. So the formula says R equals B plus KH, which is a line depending on what your inputs and outputs are, right?
Yeah.
Okay, so let's read what they've got. They've got the development time T. Well, what the hell, dude? There's not even T in that thing. Okay, so someplace over here is T. That's a time, right?
Yeah.
That's the development time of an organism. O, which is the number of days required for the organism to mature. Okay, that makes sense. And the development rate is defined as R equals 1 over T. Oh, okay.
Development rate.
That kind of makes sense, right? The rate should be kind of the amount divided by the time. Okay. In cold-blooded organisms such as insect, the development rate depends on the temperature. The colder it is, the longer the thing takes to develop.
Okay.
Yeah, that seems legit, right?
Colder means less kinetic energy.
Yeah. For such organisms, the 3-day model assumes that the development rate is a linear function of temperature H in centigrade. H. 10 degrees centigrade. Cool. According to the that thing's the 3-day model, apparently.
Yeah.
R plus,
Degree day.
or R equals B plus KH.
What's a degree day, not 3 day?
Yeah. What's a degree day? A degree day is a unit that you make when you take a degree and multiply by a day. Really? No, straight up, that's what it is. So, the interesting thing is that the scum in the pond grows according to degree days.
Oh, cool.
Like lots of organisms actually work this way. And the interesting thing about degree days is if you have an entire summer, right, which is made of how many days, give or take?
104 days of summer vacation. Oh gosh.
Okay, no idea where that came from. So if you have 104 days and it is a degree warmer than usual on average, right?
It's 104 degrees hotter that summer.
So that is 104 of these things, right? This is 1 degree Celsius warmer. You guys with me on that?
Yeah.
That is a total of 104 degree days warmer.
Oh, that makes sense.
You guys see that?
Yeah.
And the way the scum in the pond works is it's degrees basically above, I forget whether it's 40 or 50. But that's what they're asking for in this problem. They're asking what's the minimum. Like, once it gets warm enough, that stuff starts to grow, right? When it's not warm enough, that stuff just sits there being dormant. It doesn't go away, really. It just gets dormant. You guys see that? So it's the total amount of degree days over the kind of minimum temperature, right?
Okay.
So if the minimum temperature is 70 and it gets to 71 degrees, then it gets 104 more degree days than it would have had.
Okay.
You guys see that?
Yeah.
If the minimum temperature is 70 and it gets to 81 kind of on average,
So it's 11 times 104 degrees.
right, then it gets 11 times the 104, and that's 104 more than it would have had if it had been 80 degrees.
Yes.
You guys see that?
Yeah.
So last summer was a lot warmer than most. You guys see that? Which is why the pond grew a crap load of algae. Because it got a lot of extra degree days because the days were on average like 4 or 5 degrees warmer than usual.
Okay.
You guys see that?
Yeah.
So that's why that pond gets so scummy every time the summer's a little bit hotter. Like it's not a lot hotter, right? It's just got a lot more degree days. Cool?
Yeah.
That kind of makes sense?
Yeah.
Okay, so on this one, they're asking for, there's a minimum temperature below which an organism never matures. Find the H min. Okay, so if I plug H min in, I don't know what K or B are. What's the rate if it never matures?
0.
0. Does that make sense?
Yeah.
Why?
Because 0 means no, nothing happened.
How about what's the time to maturity if it never matures?
0 to 0.
Huh.
I don't know.
So
Something
if
over
it's
0.
never going to mature,
Anything over
how long is it going to take to mature?
95.
Infinite time.
Infinite time, right? If you take one thing and split it infinitely many ways, you guys see that's what I'm asking right here?
Yeah.
So what's 1 divided by infinity?
0.
It's going to be 0. Cool?
Yeah.
Okay. So my rate, right, is 0. So can I solve for h min?
Yeah.
But we don't know.
B.
Yeah, I don't know b or k. But I think I can at least start, right? In terms of b and k, I can solve for h min.
Yeah.
So what are you going to do?
B would have to be like the opposite of K.
How about b has to go to the other side, right? So how do you move? You just like trot it over there or what?
You subtract it.
Subtract b from both sides. So you got minus b is k times h min, right? And then what? And then you need to divide by k. Oh, and because we're doing pre-calculus, we'll multiply by 1 over k. So we'll get minus b over k equals h min. And what the heck are b and k?
Constants.
Yeah, those are constants that depend on what you're talking about.
Yeah, those are like,
Right, which is why I get to use this model for pond scum and praying mantises.
right, exactly.
You guys see that?
Mm-hmm.
Like, to adjust for what you're talking about, you need to change b and k around.
Right.
If it's complicated, right, like if you have a complicated organism, you're probably going to increase both b and k.
Right.
If you have, like, goop in the pond, b and k are probably pretty low. Does that make sense?
Uh-huh.
Okay. All right. So I found that. Good. Define S as h minus h min times t. S equals, what did it say? H minus h min times t. Oh, we were just talking about this amount. What is this?
Point slope form of your line of
Uh,
plus 0.
Yeah, so this looks a little bit like the part endpoint slope form, right?
Uh-huh.
Like without the y bit, this looks like a chunk of that. How about, what would the units be on this thing? Like, what's this guy? It's going to be a change in temperature, right? That's the number of degrees you are above the minimum,
Right.
right? What's the t?
Time.
Time. So this is the number of degrees you are above the minimum times the time you're spending there,
Yeah.
right? So that's going to be one of those degree day things. Like, that's the total amount of degree days you get to grow.
Right.
You guys see that? So what they're going to ask me is, that is, S is the number of days T times the number of degrees between H and H min. Use the formula for R to show that S is a constant. Whoa. Where's the formula for R?
R equals B plus KH. Is that the formula for R?
That is the formula for R. So I know that R is B plus K times H, right?
Yeah.
Okay. And I know that R is 1 over T, right?
Yeah.
You guys with me on that?
Yes.
Okay. So I know that 1 over T is B plus KH. And I really want to put an S in there. You see that? Like, I want to put this and that together somehow.
Right.
So how are you going to put this and that together?
Multiply the t, that way it's no longer the bottom number.
Okay. So you take this thing and multiply both sides by t. That seems like a legit step. So you got 1 is b plus kh times t. Okay, now what else?
Divided by b plus kh.
That seems legit, right? You figure out what t is, right? So t is 1 over b plus kh. Cool. What do you do with that piece of information?
Plug it into T over the S portion.
All right, you solve for t. And then we're going to take that and put it, yeah, that's what t is. T is also this. Take this, shove it in there. Okay, now it seems like I probably made everything way worse, right? So far I have S is H minus H min over B plus KH. Okay, what else do you know? Because right now that seems like I'm not going to get anything to cancel out of that conveniently, right?
The h min is minus b over k.
Oh yeah, I know what H min is.
Oh.
You guys see that? H min, I solved for over here. That's minus b over k. Okay, so I take that and shove it in for H min. So I got S is H minus, plus b over k H. Oops, b over k.
No
Okay, see that?
No H.
No H. Over, what do you got on the bottom?
B plus KH.
B plus KH. Okay. Now,
Don't cancel the H's.
don't cancel the H's. But dude, I want to cancel the H's.
Don't do it.
I really want to though.
Just don't cancel anything.
Yeah, you can't cancel anything. Not yet. What do you need to do?
Multiply both sides by b plus kh.
No.
Gross.
I don't know.
Yeah, you could do that.
You could multiply the top
It's
by
gonna really suck.
by
Don't
K
do that.
over 1.
I think I want to like,
Multiply the top by K over 1.
yeah, I think I want to put a like K up here. Because basically I want to get rid of this fraction, right? Okay, so I think I want to multiply this thing by K.
Both sides.
But you can't just multiply the top through by K, right?
There's no, so it's SK.
Have to multiply those.
Oh, you want to multiply both sides? Okay, sure. Oh.
Yeah.
So you want to multiply both sides by K. I'm down with that.
But do you have to do it to the entire fraction?
Well, I got K over 1, right? That help? So I think I got KS is, what do you get on the top there?
You get KH plus B1
KH plus B over,
over B plus K.
well, over, yeah, B plus KH. So, and please don't do this the silly way. What are you canceling?
The entire.
Yeah,
H
the
plus B.
entire thing is 1.
Yeah.
You are not doing the silly thing where you cancel a B, right? Because that's a false cancel.
Yeah.
But this whole thing, like this guy and this guy are the same.
Mhm.
They're dividing something by itself, you get
One.
1. And so you found that KS is 1,
Well, man.
which tells you that S is
1 over k.
1 over K. That's telling you S is constant. Right? S is like the total number of degree days this thing needs to grow.
That's crazy.
You guys see that?
Is that going to be on the exam?
Maybe.
Great.
I instantly just
That was most
I would like to untangle these two skills. Right, so there's two skills involved in here. Do you guys all see that? What are the two skills that we were asking for here?
Algebra 2 skills.
Asking for a lot of algebraic manipulation with a ton of variables, right? What else am I asking for here?
Substitution. It's algebra 2.
Yeah, so.
Like, there's a bunch of algebra. Like, all that crap aside.
And
Like,
more
The other thing I'm asking for is like, hey, do you know what the variables represent? Like,
Yeah.
what are the units? Can you
dimensional
interpret?
analysis.
Right?
significance of variables.
So I would expect you guys to be able to do those things independently at the very least. Am I probably going to ask you to do both of those things together like this problem on an exam? Not really, because I have a hard time grading it.
Or coming up with problems.
No, coming up with problems like this is easy. I just go ask the biology people or the chemistry people or the physics people. Like,
I mean, if you say so.
that's why you guys have to make that video project, because stuff like this comes up. I want you to know that. Okay, and the last thing it says is something like, a certain organism requires 25 days to develop at a constant temperature of 20 degrees centigrade and has a minimum of 15. Using the fact that S is constant, how many days does it take for this organism to develop? Whoa. Okay. But all they said was it takes 25 degrees
And 15
in,
20 days. And
it takes 25 days at 5 degrees, right?
at 20
at 20 degrees.
At 20 degrees above 15, right? You guys see that?
Yeah.
So it's got a total of 5 times 25 degree days to mature. You guys with me on that?
50 degrees.
Like, that's what they said. They said, all told, it takes 25 days at 5 degrees above min. Right? So this critter needs a total of 125 degree days. You guys with me on that? Like, that's what it needs. And then they're asking me, okay, using the fact that S is constant, how many days does it take for this organism to develop at 25 degrees?
Oh, so you just 25 divided by, I mean, this is 5 days.
So at 25 degrees, how many degrees is that above the minimum? Good, that's 10 degrees above minimum. And how many degree days does it need? It needs 125.
Right.
So
So 25 divided by 10.
125 divided by 10 is 12 and a half days.
Yeah.
Why are they saying that S is constant? Like, what's the business about S being constant? That's them saying it doesn't change, right?
Yeah.
It doesn't get different amounts of degree days depending on how warm it is. It's like what that organism needs is just degree days. Like, that's all that matters.
Oh, I understand.
Like, you can't accidentally cook it, basically.
That's cool.
You guys see that?
So it was like 700 degrees above.
Yeah, so we could do the same calculation, right? Like in an oven.
It would take like half of
And it would take like way less time because it would be way warmer.
Yeah.
You guys see that? Which is why biologists have incubators,
Oh, got you.
right? Because if you can jack the temperature above room temperature, you can grow your fruit flies faster, right? Obviously, there's some maximum too, right? Okay, and then last question. In part C, we assumed that the temperature H is constant throughout development. Uh-oh. That's probably a crap assumption, right?
Yeah, it would cross section.
So then they're saying, well, if the temperature varies from day to day, the number of degree days can be accumulated until they total S, at which point the origin completes development.
Or
Whatever.
yeah.
Okay, so in other words, it just needs a total number of degree days, right?
Yeah.
Okay, so blah, blah, blah. So the total number of degree days, based on the table, when does the organism reach maturity? So there's this whole table here, right? space. So, first day, it's 20 degrees. So this is day, temp. And then I'm asking for, I'm going to make another column over here, which is total degree days. Right, like just, what's the total so far? Right, so in one day at 20 degrees, how many degree days has this thing accumulated?
5.
Yeah, it's made 5 total degree days because it had 1 day at 5 degrees above its minimum. You guys see that? Like it earned a total of 5 points towards maturity or whatever. It needs to get to, how much?
125.
Yeah, it needs to get to 125. Okay? Second day, it's 22 degrees.
7.
So it earns a total of
7.
7 more, which means that my total accumulated is
13.
12. It's okay, like I said. Try to avoid the arithmetic wherever possible. So on day 3, we have 27 degrees,
Whoa, man.
which is another, so that's 12 degrees above the minimum, and I'm adding that to my total so far, so I get 24 total. So now we're a fifth of the way there, right? Okay, day 4 is 28 degrees, which means we're accumulating how many more today?
13.
We're getting 13 more today, and we're adding that to our
37.
24 we already had for 37. Okay, day 5, it's 27 degrees, which means I'm going to add another
12.
12 for a total of
49.
49. Can you guys continue this procedure?
Uh-huh.
Okay. So someplace down here, there will be a first number that's bigger than 125. What happens if it goes from 110 to 128?
Oh. And then it's developed.
Yeah, then it developed on the day where it exceeded, right? You guys with me on that?
Uh-huh.
So I want to draw a quick picture here, just because this is a cool picture. And it relates to calculus class pretty well. So, if I have here a time axis, and I have here a temperature axis, right? That might look something like this, right? And one day on this thing,
One cycle.
yeah, it's probably a cycle worth, right? Because it's like warm during the day and then cool at night, and then it warms up again the next day. So a day might look like this. You guys see that?
Yeah.
Okay, so depending on what you measure your axis in, right? There's that minimum temperature, right? So let me throw that in here. So for my specific organism, there's a minimum temperature, right? So what's the degree days thing that I'm talking about here? Where is that on the picture?
And it's like the height.
Would you average out the temperatures throughout the whole day?
Yeah.
Yeah, that's really kind of how you could do that. Or you could just take the area underneath this thing.
Yeah, that makes sense.
You guys see that? So this area here is, if this time is in days, and this is in degrees Celsius, this is the degree days during day 1. And I haven't even assumed that the temperature's constant all day.
Okay.
You guys see that?
Yeah.
This is actually how you do this. One thing you might consider is even degree hours instead of degree days,
Makes sense.
right? And that's if it stays hotter longer during the day, right? That's going to drive your average temp up.
Yeah.
You guys see that?
So to get to turn degree days into degree hours, you just make a conversion factor between
Yeah.
days and hours.
Yeah, exactly. You guys see that? So what I wanted is this picture of, it's the stuff underneath this curve, right?
Yeah.
That's a calculus thing. But-
Find the area underneath the curve.
Yeah, about 2/3 of the way through the first semester, one of the problems we do is, let's figure out how to find the area under curves. Right? And the way we do that, the way we start that is like this. Right? You just like chunk it up into some pieces and add up what's under the pieces. Right? Like if you wanted to figure out how big this area was, one thing you could do is you could go like this. Right? Like you could chunk it up and basically like round. You guys see that?
Yeah.
So that's a thing called integration.
Oh, that's interesting.
Yeah.
That's not that
No, the concept's pretty easy.
Yeah.
The execution gets a little bit wobbly, but the concept's pretty chill.
Yeah.
You guys cool with this?
Uh-huh.
Any questions on this whole rigmarole?
If you assume the entire temperature of day based on one measurement at like noon,
That's, yeah.
doesn't that super skew?
Yeah, that would be like saying this, right? Instead of doing some little thing where I like average this line out, that would just be like, well, I measured it at the hottest time. How much area am I different by between here and the blue?
Right. A lot.
Like a lot, maybe.
Yeah.
If I did a better job of picking my one time to measure during the day, right? Like, how much different would that be?
Not much.
Not as different.
Probably
Are you
not.
saying- yeah, okay.
Yeah, like it's still a model, right? It's still kind of a guess, but it might be a better guess.
Yeah. You use just
So-
as you can.
Yeah, this is actually how you would kind of like figure out what an average daily temperature is,
Yeah.
right? You don't have constant measurements. Like that's just not possible. Even with little remote weather stations, right? They still do a measurement and then record it, and recording takes all its processing power for a second, and then it takes another measurement a second later, right? So even in that case, you still have like 1 second tall little blocks, right?
Right.
But you just add them all up and average, right?
Right.
Cool?